László, are you ready? Sure. Okay, because we are making a video of this event, please stand somewhere there and okay, start.
Okay, so welcome everyone. My talk would be about some experience in exploratory data analysis projects and some ongoing developments done in our company. I will not show any piece of R code, so this will be maybe an exceptional talk in that sense. I will concentrate on project experience coming from projects heavily relying on the application of R language. So why do we use this exploratory approach, which is relying on linked interactive plots and visual analysis? We think that this is a good tool to support, to find the key attributes in a system and can be a driver of further automation. What are the challenges in such projects? First, if it's not a concrete software development project, and as in our case most days, then a big question is to clarify with the customer what to improve in his existing system. So whether it's the price of the current system or the performance, and what are the key applications or the key data sources which we can rely on. So some examples here, just read the second one, and imagine when we are doing a project for 3 months and then having, of course, R script and everything like this, and then just we receive a feedback like this from a customer. And of course, this is, let's say, influenced by the stakeholders being not very competent about their own IT systems and their own data, so the data is usually dirty, and which is a bigger problem for us. There is no common language even between IT people, so it's quite hard to model data which is coming from dynamic systems. So systems and the workflow is changing, so the data dependencies are changing in time, which we have to handle somehow during the data cleaning and the data analysis phase of the project. This is another example. This is when we were processing some IT measurement data coming from our internal virtualized infrastructure, and the amount of data is quite big here. It was reflected in some earlier talks here in the R meetups. And we have to identify the data sources and the topological interconnections between them. And an interesting result of one of our projects was this. This is quite an ugly figure coming from iPlots. It's a parallel coordinates, and people first were afraid from such plots, but after a second meeting they were just arguing about the results shown in the plots. So they really loved to see even this very preliminary kind of feedback of their system, and they were quite keen on, let's say, understanding the plots and explain even to each other what their expectation about their data was. So these are, of course, mass data from real projects, and these were shown to real but non-data analysts and non-IT people. And of course, we have some, let's say, approaches for data analysis projects, but we, of course, can never follow one of these approaches cleanly. But we always have to go here and there between the steps, which results, of course, re-implementation of some scripts, and of course can modify our analysis approach. And this is just a figure about what sort of competences are needed in a data analysis project in our view. And a very important one is, which is of course cross-cutting, is the domain knowledge. So the knowledge of those different domains. What is missing in current tools to have to represent these domain knowledge? So first, if we are doing an interview, how to derive an early high-level data model of that, how to connect it with the data cleaning process, how to connect the automated and visual parts of our analysis approach, and how to back annotate the results to the model. So what we are working on now is to create, let's say, a tool set which is relying on a knowledge base represented in RDF, so it's a sort of graph database, connected to data sets. This is done in Python and R. And then after an analysis phase, back annotate our findings to the original model, which can be a model like this. This is a free tool. It's a mind mapper tool which we use in a way to represent a high-level view on a system and the data. And the goal of this tool is to help the user to categorize and prioritize the data and the questions about the data. And behind this tool are there R-based technologies. So our experience is that exploratory data analysis can itself be sort of great success. It can connect different stakeholders in a project in a very smooth way. It can scale up with the problem. Imre will tell a bit more about this a few talks later. And it can really help to disprove, let's say, false user expectations about their own system and behavior of their own system. So this was more a high-level talk than a technical R-related talk, but this was the first introduction to our experience.
And you even gave a talk 10% longer than you should have done. But anyway, thank you very much.
Sorry for that.
Any questions? Imre, please.
Let's try and get a bit more technical. Okay, so I will talk about plotting relatively large data in R, specifically using the Bigvis package. The Bigvis package is developed by was developed by the well-known Hedley-Wicken. So this is only scratching the surface of his work. I will reference the paper that those who are interested in it should read. Now, our basic tenet is that let's do exploratory analysis. Let's grab biggish data, namely the schoolbook flight data. For 2008, this constitutes a 113 megabyte data frame, 7 million flights, 29 variables, and we can do it because we wait and wait and wait, and nothing happens. What we can see is that relatively painless tools that can enable us to relatively painlessly handle big data and tools that can do visual exploratory data analysis well are quite distinct, and nowadays building the connection between the two is still quite an artisanal experience, so to say. Now, Bigvis is actually a reference implementation in R for a quite generic approach. Its immediate usage is that you can get quite a huge boost from ggplot2 by doing something that is almost big data exploratory data analysis. Now, the basic tenet is that sum signaling is a hassle. It's not EDA really. You probably want to see the whole data, bird's eye view, and summary statistics over interval binned data to that. Error approximation and suppression of outliers would be nice too. Practically, this means that while you can do in ggplot scatter plots, and you have to wait and wait and wait and wait, that's 10 minutes on my machine or so. With Bigvis, you can do the same in half a minute or even much less. What you pay for that with is that you have a heat map. The simplified workflow of Bigvis is that you begin with data in memory. Variable by variable, you do an interval binning. You condense the data using count, sum, mean, median, or standard deviation. Count can work on a single variable. Mean and the other can work on not binned variables. Then you can smooth out the quantification artifacts, peel off outliers, and the data structure that you get at the end of this simple workflow is already amenable to visualization in ggplot. And actually that's it. In a few lines you can, for instance, visualize the distance distribution of the data that we began with, and you can even do some nice kernel density estimation on that. Now, the Bigvis package can do and actually does some further automatic magic with kernel density estimators. There is also possibility to handle error estimation with alpha values and hues, and there are visualization patterns for n-dimensional data sets. What is more interesting from the engineering point of view is that this whole workflow can be parallelized and the steps can be decoupled from each other, meaning that the binning can be done outside of R. For instance, in MapReduce, a map step can be a binning step. Summarization can be done in a reduce step. Specifically, there are some summarization statistics that can be done very efficiently even in stream processing. These are the distributive and algebraic ones. For holistic ones, you have to make some sacrifices. Smoothing can be done in a backend infrastructure too, and at the end, we get a smallish data structure that is mostly bound by the resolution of our visualization or our screen, and R excels at that step. Yeah. Okay, what is still missing and what we do not have reference implementation for, at least to my knowledge, is exactly this decoupling of concerns. Being summarized mood can still be quite long or longish, but you can do pre-computation or caching if you like, and you can use these values stored in an RDBMS or even an in-memory database to visualize big data in an almost interactive way. So, that's it. Questions? If there are.
Maybe later.
Go.
Hello everyone.
Can we start?
Let's go less technical again. I just submitted my thesis last week and I will share that with you. It is about how can you detect changing user roles in an online forum. And hopefully we'll see soon. So one main question that how can we find these user roles, and the other is how can we detect their change. The change is defined by the user. So we have, for example, roles, and they will become maybe opinion leaders or something else. We don't know, and we want to find it. For this, first I have to find features of users to find some patterns. Then I have to find the most important variables. I did this with principal component analysis, and then I used cluster analysis. So I, of course, used R for it, and the most surprising thing for me was the compiler package, which is in the base package or in the base installation. This is how a thread looks like. Forum consists of more of these threads. This is just stolen from the internet, so it's not exactly a good example. But one can see that there is a root node and a child and parent nodes. Maybe if someone has know enough of the three graphs. The most important features were the number of neighbors and number of posts which indicates activity, and parent users in activity was another important feature of the users. All these variables are heavily distributed. So the principal component has analysis has some mistakes on it, but I tried a more robust one, and it was good. Hierarchical cluster analysis was applied because I had to. I didn't know how much clusters I want to have, and it is an interesting task to find how much cluster should I look for. First, I use several cluster goodness measures to find the ideal numbers of clusters. I search for the first local maxima or minimum, and if there was no such a thing, then I search for the sharpest elbow, which can be seen, for example, here, and you can see that there is several minima and maxima around this number of clusters, and each measure had one mode for the number of clusters. So for the change, I use time windows. One window contains 100 posts, so it is not exactly time windows. And I extended back to the full thread. Then I detected a search for the user roles and tried to link each clusters to each other by finding significant connections between each other. Here is an example. We can see here the time, and each of these are different clusters, and red lines show new groups joining the forum. Gray lines signal the leaving groups of the forum. One can see that here are some new users who began to ask really high users with really high degree, but mostly they asked the small fishes who had less activity before. That's all. Thank you.
Questions?
Okay.
Yeah, start. You can start.
Hi, I'm coming from the Brain Imaging Center of the Indian Academy of Sciences, and now in this talk I'd like to share with you my dilemmas which arose during developing a package for electrophysiological data processing, which would demand interactive visualization, graphical user interfaces, and largish data. And what is EEG, electroencephalography? Actually the recording of voltage fluctuations at the scalp. And the data sets are pretty large, so can be 2 gigabytes per participant, and we have in an experiment 20 to 30 participants, and this is actually the EEG recordings for each channel, and you can see that this is actually a workflow process. So you do signal processing steps, filtering, ICA, topographic interpolation, etc., and then in the end averaging. Why averaging? Because in these cognitive experiments we are not interested in the EEG, but in the changes and changes of the EEG to different stimuli. And we have to extract the components, the latent components, and do a lot of statistics. And this is, in the end, for example, you can see the brain response to the black condition compared to the red condition. No, it doesn't matter what is black condition and red condition. And this is a well-known commercial tool for data analysis, which is extremely good for interactive visualization, but not good at statistics. And in R, there isn't any dedicated comprehensive package for EEG processing, but there are a lot of related packages. And right now, my package, the EEG-R, is rather a collection of functions, which is suitable for my specific workflows. In the future, it should be highly extensible with workflow and GUI and easy scripting as well. Should handle well out-of-memory data sets and allow easy parallelization, and of course provide interactive visualization capabilities, which is maybe the hardest task here. And there are some questions which I need your input actually. For example, should I build one package or a pool of related packages? I think this would be the better choice. But of course, in this case, the core package has to be very well written, because I would think that others should develop the specific statistics. And I don't know if I should provide only the classes, methods, and utility functions in this core package, or some basic processing as well, and which classes do we need for this. And for the workflow approach, which is very good in the signal processing part, I don't know if you know the R analytic flow tool, which does exactly the same. So it allows you this workflow-like analysis. And of course, the second question is, what about the user interface? It should be, I think, a subtask-related GUI, so functions-related GUI, not a full GUI. And I don't know if it's it should be a desktop graphical user interface or rather a web-based like Shiny, for example. Third question, which out-of-front package shall I choose? SciDB would be great, but it's platform dependent, only available on Linux. So the other two candidates could be the FF package or the GD SFNT package. And the third question is how to achieve interactive visualization. So yeah, the basic packages are good but inefficient. And there are performance issues if you would like to plot more than 1 million data points. The candidates for line plots are, for example, the Asynonix package, so very fast, and the iContainer would be perfect in my scenario, but really very poor documentation. The other is the R charts with the JavaScript libraries. Of course, the JavaScript is very good at this interactive plotting, but it's still not well implemented in R chart, for example, the digraphs library. And thank you. Here are the reminding questions. So the take-home message that you should, with a beer, share with me your suggestions. Okay, thank you.
Any quick feedback for the questions?
Are you serious about Asynonix?
Hmm?
Are you serious about Asynonix?
What do you mean serious?
Well, we tried it and didn't seem, how to put it nicely, obsolete.
Yeah, so actually I would go with the R charts and JavaScript stuff. The problem is that I do not know Java and JavaScript. So that's the problem, and because it would be better because I wrote, for example, 3 emails for Simon Urbanek, the developer of the Asynonix, and didn't get any answer. Although I asked really basic question, for example, how to close a device, because I cannot close programmatically the device just by clicking on it. And of course, for this aim in a GUI, I would like to have an interaction between my GUI and my Asynonix plots.
I think the last version of Asynonix is only 2.5 years old.
Yes. Yeah.
At my talk, it will concentrate on a lot simpler topic. This is the first slide, so my time not started. So I will give a talk on how to turn R objects to simple Markdown. So nothing, no complex statistics, math computation, and so on. I would like to create simple text documents in the R console. What I came up with is a small package called Pandoc with a bunch of helper functions. As you can see here, for example, if you evaluate pandoc.strong function, it will return the string between 2 stars, which stands for bold text in Pandoc. And you can see some similar functions here, like to create a header and Pandoc and so on. We can create some simple lists that can be later converted to HTML, PDF, Word document, and so on. And what's the best part is here to create tables. So you just pass the head of the iris database and you get that 2 rows in Pandoc's Markdown, which can have multiple new lines in a cell and so on. But we can also return in other formats. For example, there's the R Markdown style, which was called originally the PHP extra Markdown, which is used by Knitter and the RStudio tools. We can also return in simple tables, which does not support new lines in the cells, but it's rather human friendly. Or we can return in grid style, which has a bunch of other options. For example, we can automatically split the strings, for example, fools and bars, if we said that we need cells with no more than 5 characters, and it's cool to edit in Emacs, for example. So that's how we can turn our tables, data frames, matrix and other formats to Markdown, but we have a general S3 method. You can see it's working for a few R classes, so that you can simply call Pandoc on an R object, no need to call directly the R helper functions, so that it would return Markdown automatically based on identifying the R class of the object. For example, it can return a vector, as you can see at the top of this slide. We can run it on a few statistical tests, so that you don't have to know, for example, what important values are to be extracted from different statistical tests, but it's working like something like Stargazer, but of course in a lot simpler way, because Markdown cannot support, for example, row spans and a few other important features, but it's working more or less. So just calling Pandoc on a linear model would return a table like this one, and we have some other features here also, so that, for example, you can highlight some cells in the table. For example, if we define here to highlight those values which are higher than 1.3, all these values would be returned with an emphasis, and all the other values would not get any extra formatting. So this way you can just programmatically highlight some parts of your tables. And Pandoc also have some features for literary programming and reproducible research like Brew or the Knitter packages. Here you can see the syntax. We have some R chunks here which are evaluated and returned in Markdown after calling Pandoc Brew. Here you can see a few features of this package, and maybe it's a good summary of why I started writing this Pandoc package, because of course we had Brew at the same time, Knitter was started, but I needed some unique features which was not supported by other tools. For example, Brew can run on loops and conditionals in reports, which is not supported by other engines, for example by Knitter, and it's a pretty cool feature. For example, if you want to run the same report on a data frame, on all variables in a data frame, you can just do this with 5 lines or so. You just iterate all the R scripts on the different parts. And what I really like in this package is the global options for graphs. So for example, if you define your global options like the color of the plots, the grid system, the axis label, angle, and so on, it would be applied to all your plots. So no need to pass extra values to your ggplot or lattice plots. It would be automatically applied and all your plots would look the same. So if you have some favorite colors, you just define it in your R console once and it would be applied to all your plots. And we have a few cache options so that long queries will be run only once, and it doesn't matter how many times you need to run that, it will be returned in a millisecond. Here you can see some other literary programming tools, and the most important thing is that Pandoc was created for this global option, what I discussed before. So you just define once and run any number of times. Can we go back one slide, please? Thank you very much.